first vaccine was developed in the 18th century against smallpox disease, which was caused by poxvirus. Even before this official vaccine, people would scratch lesions of smallpox infected people and inoculate non-infected people to protect them against smallpox. An innovation in the use of this vaccine was to use cowpox virus as an immunizing agent rather than human poxvirus. Before cowpox was cultured, lesions of cowpox-infected milkmaids or lesions from udders of cattle that had cowpox were used for inoculation of susceptible people. However, since very few viruses have a safe animal alternative, other techniques for vaccines are used. Most bacterial and viral vaccines are administered by injection. So let's look at viral vaccines. The first one is killed or inactivated vaccine. So what's a killed or inactivated vaccine? A killed or inactivated vaccine has viral particles that have been treated with chemicals, heat, or irradiation such that they are no longer alive. For example, influenza virus vaccine and the rabies virus vaccine. There's another viral vaccine called the live attenuated vaccine. And what is a live attenuated vaccine? This vaccine has a live virus with a reduced ability to grow in humans and is processed for vaccine purposes. These are more potent than killed vaccines because they more closely mimic a real infection. Most viral vaccines of that type, for example, measles, mumps, and the rubella vaccine, are examples for this live attenuated vaccine. Now, there's also another vaccine called the subunit vaccines. And a subunit vaccine is a vaccine that uses only a particular component of the virus rather than an entire virus. So usually these components are given as proteins, which were translated in bacteria or yeast. And an example of this is hepatitis B. So let's transition to bacterial vaccines. There's a small number of live attenuated bacterial vaccines, for example, Salmonella and Mycobacterium tuberculosis. However, since many bacterial diseases result from toxic proteins secreted by bacteria, there are toxoid vaccines against certain bacteria. These are made from purifying a toxin and inactivating it with a chemical called formalin. For example, many other bacteria have very pathogenic capsules, and a pathogenic capsule is a polysaccharide structure covering the surface of the bacteria. This structure is not immunogenic in that it cannot complement very well, but it can elicit an immunoglobulin response. Therefore, subunit vaccines have been developed against a purified capsule. Often, these are administered as conjugate vaccines, where the capsule is conjugated to a carrier protein to make the capsule more immunogenic. Let's quickly talk about adjuvants. To be effective, a vaccine must create a state of inflammation. Therefore, helper substances that induce inflammation are used in conjunction with a vaccine. These substances are called adjuvants. An example of an adjuvant is aluminum form of aluminum hydroxide. Let's now go over the problems with vaccines. Live attenuated vaccines can, in some instances, revert to becoming pathogenic. This happens rarely, and if the vaccine is thought to provide much more benefit than harm, it is still recommended. In general, live attenuated vaccines have some advantages over inactivated vaccines. They are more effective, provide lifelong immunity, do not need repeated boosters. On the other hand, the advantages of inactivated vaccines include their stability and ease of use of transportation, as well as the lack of risk associated with vaccine-related illnesses. When a person is vaccinated by either of the above-mentioned vaccines, he develops active immunity. Lastly, for today, we're going to go over passive immunization. This is used when exposure to a pathogen has already occurred and there's not enough time to induce active protective immunity, or prophylactically in children with immune deficiencies. Passive immunization involves administration of a specific antibody which has been produced in a human or animal in response to vaccination or environmental exposure to the pathogen. Examples include antivenin for a snake bite, anti-Rh antibodies, and human gamma globulin given to children who have immune deficiencies. Passive immunization can confer fast but short-term protection. When the antibodies come from another species, serum sickness, which is type 3 hypersensitivity, may also result from complexes of the foreign Ig with antibodies made against it.